Okay, this question says quadratic function f can be written in the form f of x is equal to a times x minus p times x minus 3. The graph of f has an axis of symmetry x equals 2.5 and a y-intercept at 0, negative 6. Alright, so we're going to try and sketch this. So we're going to have some axes like so. Now we know that there is a point, because we've got this here, x minus 3, when this is equal to 0, x would have to be 3. So there'll be a point where it intercepts the axis at x is equal to 3. So I'm just going to put that, say here, that will be 3. It's also told us that the y-intercept is at 0, negative 6. So there's going to be a point down here, negative 6 on the y-axis. This is the y-axis, this is the x-axis. Alright, and then we know that there's an axis of symmetry at 2.5. So the graph is going to have to be symmetrical around a point like that, which is 2.5. Okay, so our curve is going to be, because it's a quadratic function, it's going to have to be either a happy face like this or a sad face like that. It's got to go through this point and be symmetrical about here. So it's going to have to go something like that. So let me see if I can draw that in. Something like that. That's not perfectly symmetrical, but you get the idea. So it's going to be symmetrical about here. Let me just move that line over a bit. Like that. That's 2.5 there. And then it's going to cross here and cross here. So the graph isn't quite to scale, but you should be able to see. Since the distance between here and here is 0.5, between here and here would also be 0.5. So this point of intersection here is going to be 2. So where it says find the value of p, x minus p, for the same reason this is x minus 3 is where it cuts here, and this is point 3. This is x minus 2 because it cuts here at 2. So the value of p is equal to 2. Alright, next it says find the value of a. So we can now use, we know that this is 2, we know that this is minus 3. We can then use this point here to work out what a is. So I can say that negative 6 is going to equal a, and then x has to be 0, so it's going to be 0 minus 2 and then multiplied by 0 minus 3. So that's going to give me negative 6 is equal to a times by 6. So that's going to give me a is equal to negative 1. Alright, then next part, it says the line y is equal to kx minus 5 is the tangent of the curve at x. Find the values of k. So we're going to have a tangent which has got to cross at this point down here, negative 5. So our tangent is going to look something like, another colour here, something like that. Alright, it's just going to touch the curve at one single point there, go through the point negative 5, and so what we're going to want to do is to work out the gradient of this blue line which I've drawn. That's the tangent to curve f. We're going to find values of k. So the way I'm going to do this is these two are going to intersect at some point. So I'm going to set kx minus 5, which this is part C, kx minus 5 is equal to the equation of the curve is equal to negative x minus 2 times x minus 3. So I can then multiply that out and get kx minus 5 is equal to negative, that's going to give me x squared minus 5x plus 6. So I can then rearrange that, move all this to this side. Because of this negative, it will end up being positive on this side. So I would have x squared minus 5x, and then I've got plus 6 and then minus 5, so it's going to be plus 1. Oh, and I'm also going to have plus kx plus 1 is equal to 0. So I can then write that x squared and then plus k minus 5 times x plus 1 is equal to 0. Now, because I said there was only one point where the tangent is going to meet the curve, where this blue line is going to meet this purple line, it's only going to have one solution. Okay, just one solution, because there's only going to be one point where the blue line touches the purple line. So because there's only going to be one solution, we can say that the discriminant will have to equal 0. So b squared minus 4ac will have to equal 0. So a is going to be 1, b is going to be k minus 5, and c is going to be 1. So this is a value for the discriminant here, b squared minus 4ac. Because there's only one solution, this will be 0. And then I've assigned the values of a, b and c from the quadratic here. So a is the number in front of the x squareds, coefficient of x squared. b is the coefficient of x, which is k minus 5, and then c is 1. So I can then say that k minus 5 squared minus 4 lots of 1 times 1 is equal to 0. So using that, I can multiply this side out. So I'd have k squared minus 10k plus 25 minus 4 is equal to 0, which will give me k squared minus 10k plus 21 is equal to 0. I can then factorize this. So I need numbers that multiply to make 21 and add together to make minus 10. So factors of 21, 3 and 7, 1 or 21. So if I was to use negative 3 and negative 7, they would add to make negative 10. So I can say k minus 7 and k minus 3 is equal to 0, which would give me k is equal to 7 or k is equal to 3. Those would be the solutions for the gradient of the line which would intersect with the curve here. K is 7 or k is 3. Okay, so this question says, following table shows the probability distribution of a discrete random variable a in terms of angle theta. So then it says a, we've got the probability here, and then number 1 we've got cos theta, number 2 we've got 2 cos 2 theta. Part A says, show that cos theta is 3 over 4. Alright, so because these are probabilities here, what we need to realise is these are the only two possibilities, so therefore the probability of this event and plus the probability of this event is going to have to equal 1. So first thing to realise is that cos theta plus 2 cos 2 theta is going to have to equal 1. Now what we're going to need to do next is to work out how to proceed from here. So here we've got double angles. We've got cos 2 theta. So whenever you see either cos 2 theta or sin 2 theta, you can be fairly sure you're going to need to replace it with the double angle formula. So I'm going to flip to the formula sheet here, and we've got double angle formula here. This is the one for sin 2 theta, but the one we want is cos 2 theta. Now there's a couple of possibilities. We could use the cos squared theta minus sin squared theta, or we could use the 2 cos squared theta minus 1, or we could use the 1 minus 2 sin squared theta. So keep all of those in mind. Now because we've got here cos theta, and then we've got more cos thetas here, if I change it for the one that says cos squared theta, then I'm going to end up with a quadratic with cos. So what I'm going to do is change it for this one, 2 cos squared theta minus 1. So I'm going to change out the cos 2 theta for 2 cos squared theta minus 1. Well, that'll be times 2. And keep the cos theta from here. Equals 1. Now I should be able to rearrange that into the form of a quadratic. Rearrange this into the form of a quadratic equation for cos theta, and then solve that, and hopefully that will give me the answer. Cos theta is 3 over 4. So I can say cos theta plus 4 cos squared theta minus 2, and then minus another 1 is going to equal 0. So I can say 4 cos squared theta plus cos theta minus 3 is equal to 0. Now what I want to do now is I want to be able to factorise this. So I need two numbers that will multiply to make negative 3, and then I'll need to split up this 4. I could either split it up into brackets with 2 and 2, or with 4 and 1. So I think that 4 and 1 is going to work. So I can put 4 cos theta here, cos theta here, and then I can look for factors of negative 3 to put here and here. So if I put negative 3 here, plus 1 here, I can do 4 times positive 1. 4 times positive 1 would give me 4, and then minus 3 cos theta would take those away, would give me the cos theta I need here. There's various ways you can go about factorising that. I'm not going to cover this here, but this would factorise into this. So I could then say it would follow that cos theta would equal to 3 over 4, or cos theta would equal to negative 1. Now this answer here, this doesn't make sense because we're talking, if we go back to the question, we're talking about probabilities here. So probability cannot be negative. So I can disregard this answer here. So that one we can cancel out because probability cannot be negative. Alright, so that just leaves me with this one. Cos theta is 3 over 4, which is what we wanted. So that's part A done. Fantastic. Next it says, given that tan theta is greater than 0, find tan theta. So the way I want to go about this is, if we draw a triangle, right angle triangle like so, and if I label this angle here theta, now because cos theta is 3 over 4, cos is equal to the adjacent divided by the hypotenuse, so that this angle here was theta, this would be the hypotenuse here 4, this would be the adjacent here 3. Now because this is a right angle triangle, I could therefore say that this side would be 4 squared, take away 3 squared. 4 squared is 16, 3 squared is 9, so 16 take away 9 is 7. So this side would be the square root of 7. From that then, I can then work out that tan theta, using my trigonometric function, tan theta is equal to the opposite over the adjacent, so root 7 over 3. Alright, there are other ways you could do this. You could potentially use sine squared plus cos squared is 1 and you do it that way, but tan theta is root 7 over 3. I find it easiest just to use the triangle there. So that is part B. And then lastly we have part C. Let's just go back and read what that says. So it says, let y is equal to 1 over cos x, for x is between 0 and pi over 2. A graph of y between x is equal to theta and x equals pi over 4 is rotated 360 degrees about the x-axis. Find the volume of the solid formed. Alright, so this is a volume of revolution question. So we're going to have a graph of a cos wave, or actually 1 over cos wave, and then we're going to rotate that 360 degrees about the axis. We need to find the volume of revolution. So you should recall that volume of revolution is equal to pi multiplied by the integral of y squared dx. That is how you work out the volume of revolution. So what we're going to do then is use that substituting in the value of y that we've been given. So it said that y was 1 over cos. So we're going to have v is equal to pi times the integral of 1 over cos. Is it 1 over cos x, was it? Yes, 1 over cos x dx. Now that is squared, and then the limits are between pi over 4 and theta. So we can put the limits in here, pi over 4 and theta here. Alright. So I can then simplify that here. So I can say v is equal to pi multiplied by the integral of 1 over cos squared x dx between the same limits, pi over 4 and theta. And then here what I need to do is integrate 1 over cos squared. So if I go back to the formula book which we had here, let's scroll down to calculus. Why isn't that loading up now? Gone too far. Yes, here we go. Right, if I look in the derivative section, here it says derivative of tan x, it says f of x is tan x, then that differentiates to be 1 over cos squared x. So that's the function I've got, so that's what I'm trying to integrate. So if I integrate, I go back the other way. 1 over cos squared x will integrate into tan x. So I can therefore say that v is going to equal pi and then square bracket tan x between pi over 4 and theta. Now we should remember that tan of pi over 4 is equal to 1, and the tan of theta is the value that we had from our part B back here, where we've written here tan of theta is root 7 over 3. So therefore this equals 2 pi and then multiplied by 1 minus root 7, no, why have I written there? Root 7 over 3. Alright, and that should be the answer.